Hello and welcome to another concept video of Dissect Edu Solutions. This video is for least common multiple, and if you have not already seen the DIY video for least common multiple, then I would suggest that you watch it first and then come for understanding the concept here. So what is a least common multiple? We have all learned about multiples when we were young. We have studied tables, right? 2 ones are 2, 2 twos are 4, 2 threes are 6, so on and so forth. So when you select a number, its multiple is that number repeated again and again. So for 2, it would be 2, 4, 6, 8, 10. You keep on adding that number to itself. For 3, it would be 3, 6, 9, 12, 15, so on and so forth. Now, when you have two numbers, some of the multiples will be common, and whatever the common multiple, they keep on repeating after the same amount of intervals. So for example, for 2 and 3, the common multiple is 6. In both their tables, 6 appears, and after that, it will again appear, the common multiples will again be 12, or it will be 18, so on and so forth. But the 6 is the first common multiple between 2 and 3. So the first common multiple between a set of numbers is the least common multiple. That is as simple a concept to understand there is. Now, where do we use this concept of least common multiple? A very interesting question. Let us look at actual application of least common multiple. So imagine you are making a building, right? And you have a porch area. So there's this front area which you have in front of the building, and you want to put some tiles. Now, you like a particular kind of tile and you have measured the tile, but you are not sure if you want to make horizontal rows of those tiles or you want to put the tiles in vertical columns. If that is the situation, then how would you decide how much porch you want to keep so that no matter what orientation you keep for the tiles, you don't have any problem, no wastages. The tile would fit properly whether it is arranged horizontally or vertically. How do you do that? So this is a problem which can be solved using LCM. Let us see how we can do it. So let's say you have a tile which is very similar to this. There is a breadth of the tile is 20 centimeters and the length of the tile is, say, 35 centimeters. So breadth is given as 20 centimeters, length is given as 35 centimeters. And the question is, what would be the smallest porch length using this tile without cutting? So no wastage, regardless of the orientation. So whether it is arranged in horizontal or vertical, it doesn't matter. The porch would be adequate and perfect to fit in both orientations. So let us look at that. We find the factors of both these numbers, 20 and 35. Yes, even though we are trying to find out what is the least common multiple, the method to do it is by finding the factors of these numbers. So again, we'll use prime factorization for finding factors. And for 20, we would get 2 into 2 into 5. For 35, we would get 5 into 7. Now, there is only one catch or one thing that you need to remember while calculating the LCM. You write all the multiples between these two numbers, except wherever you have a common factor, you write all the factors, wherever you have common factor, you write it only once. So what will happen in this case? So it will be 2 into 2 into 5, which is common. You will write only once, and then 7. So 2 into 2 into 5 into 7, you get 140 centimeters. So 140 centimeters is the multiple of both 20 and 35. And this is the smallest multiple. The next multiple would be 280 centimeters. So on and so forth. It will keep on repeating, but 140 centimeters is the first multiple which is common between both of them. So it is the LCM, least common multiple. Now, where do we use this concept for least common multiple? We've just seen this one example, but what about the other examples? Well, um, you can find out least common multiples. You can use least common multiple in many cases where there is repetition of things. So imagine there are three bells. We are talking about the left hand side of the screen. There are three bells and they are ringing at particular time interval, but all of them have different time intervals. So let's say the first bell rings after every 15 minutes, the second bell rings after every 20 minutes, and the third bell rings after every 35 minutes. So if you want to find out when they will ring together, if they had rung at 12 o'clock together. So if you want to find out this kind of an answer, you can find out using LCM. The second application, which is a very real life application, is if you want to find out the time or the year when all the planets would be aligned in a straight line with respect to Sun. So they would all align together. Currently they are all at very different places. This happens as a very rare moment, rare time in the whole solar system when all the planets are in a same line. So how you can find out, each of the planet has a different time interval it requires for going around the sun. I'm talking about the revolution. So each of the planet is taking different time for revolving around the sun, but at some point in time they were together. We know that by observations and calculations, we know that at some point in time they were together, and using LCM, we can also find when they will be together so that they will form a straight line. So this is the kind of problems that you can solve using a simple concept of LCM that we saw. Hope you enjoyed this video and understood the concept of LCM. If you have any doubt, you can definitely go back to that part of the video and understand the explanation. Happy learning.
All the materials used in this activity are available in Dbox along with other learning and teaching aids. For more information on Dbox for home use, school program and CSR program, visit the link given in the description of this video. If you found this video helpful, then please hit that like button and share it with your friends. And if you have still not subscribed to our channel, then do subscribe and click on the bell icon to get all updates. We hope to see you in our next video. Happy learning.